So hello students, today we are going to start the new unit. The name of the unit is the solid states. So our haloalkane and the haloarine, this unit is complete. Now we are going to start the new unit. The unit is the solid state. That is the first unit of our syllabus. Now in the solid state, there are two important terms. One is crystalline solid and other is amorphous solid. Now what is crystalline solid? Now solid means a solid substance is made up of particles. Suppose this marker pen is a solid substance, so it is made up of the some particles. So every solid substance, not only solid substance, any substance, either it is liquid or gas, any substance is made up of the some particles. So this solid, crystalline solid is made up of the some particles. Amorphous solid is made up of the made up of the particles. So in crystalline solid, suppose these are the particles. Amorphous solid, these are the particles. Now solid, in crystalline solid, the particles are arranged in some regular arrangement. So there is a pattern of arrangement of the particles. So in a solid, if the particles are arranged in a regular patterns, then the solid is called crystalline solid. But now look at this arrangement. In this arrangement, there is not a pattern of the arrangement of the particles. Their particles are distributed randomly. There is no regular arrangement of the constituent particles. So in a solid, if there is no regular arrangement of the constituent particles, then the solid is called amorphous solid. So a solid is made up of constituent particles. If there is regular arrangement of the constituent particles, then the solid is known as crystalline solid. And if the particles are distributed randomly, there is no regular arrangement of the constituent particles, then the solid is known as amorphous solid. Now, this is one point of difference between crystalline solid and amorphous solid. Second point of difference is that now, if we choose a direction, suppose this is one direction, this is another direction, suppose this is direction A, it is direction B. Now suppose this is another direction, let's say it is direction C. Now there are three different directions. Now number of particles in all directions is not same. Suppose in A direction there are maximum number of particles. In B direction there is no particles. In C direction there are less number of particles. So if we choose a directions, the number of particles in different directions is different. But here if we choose the different direction randomly, because it is A, it is B, it is C, the number of particles in all direction is approximately same. So in crystalline solid, the number of particles in different direction is different. But in amorphous solid, number of particles in different directions approximately same. Now that's why here A, B, C, number of particles is different. So if we measure the different physical properties in different directions, the value will be different. Because number of particles in different direction is different. Now if we measure the different physical properties, for example refractive index, if we measure the refractive index in different directions, the value comes out different. But here if we measure different physical properties in different directions, the value will be approximately same. So that's why this term crystalline solid, the different physical property comes out as different. So this is called anisotropy, and it is isotropy. So anisotropy means value of value of different physical property will be different in different directions. So this property is called anisotropy, that is crystalline solids are anisotropic in nature. In amorphous solid, the value of different physical property in different direction comes out the same. This is called isotropy. That is, amorphous solid is isotropic in nature. So this is another point of difference. Crystalline solids are anisotropic in nature. Amorphous solids are isotropic in nature. The first point of difference is that in crystalline solid, the constituent particles are arranged in a regular manner. There is a pattern of arrangement of the particles. But in amorphous solid, there is no regular arrangement of the constituent particles. That is, particles are distributed randomly. Second point of difference is that crystalline solids are anisotropic in nature. What do you mean by anisotropy? That is the value of different physical properties along different direction will be different. Amorphous solids are isotropic in nature. That means the value of different physical properties in different directions will be same. Third point of difference is that crystalline solid have a sharp melting point. It is a fixed melting point. Suppose if the melting point is 60 degree, so it will melt as nearly 60 degrees Celsius. So it has a fixed melting point. But amorphous solid does not have a fixed melting point. It has a range of melting point. Suppose 50 degree to 60 degree. So in this range, the amorphous solid will melt. But crystalline solid, there is no range. It has a sharp melting point. Say it is 50 degrees Celsius. So it will melt at this temperature. But amorphous solid, there is a range of temperature for the melting point. It does not have a sharp melting point. This is another point of difference. Fourth point of difference is that crystalline solid have the fixed enthalpy of fusion. In your first year, you have in thermodynamics, you come across the enthalpy of fusion. So it is a thermodynamic term. Enthalpy of fusion, it is a thermodynamics term. So crystalline solid have a fixed enthalpy of fusion, but amorphous solid does not have a fixed enthalpy of fusion. Next point of difference is that when crystalline solid it break with sharp edge. When crystalline solid break down, it break down with the sharp edges. But amorphous solid, when it break down, it does not break down with the sharp edges. So this is some point of difference between crystalline solid and amorphous solid. Next, Types of crystalline solid. The crystalline solid can be classified in different categories. There are different types of crystalline solid. So what are the different types? One is ionic solid. One is ionic solid. Another is molecular solid. Another is covalent solid. And last one is metallic solid. So depending upon the nature of particles and the particle attraction, we know that in a substance there is interparticle attraction. So depending upon the nature of particles and interparticle force of attraction, crystalline solid is classified into ionic solid, molecular solid, covalent solid, metallic solid. So in crystalline solid, there are some particles. So these are the particles of the crystalline solids. So depending upon the nature of the particle, what are the nature of these particles? So depending upon the nature of these particles, and we know that between the two particles there is some kind of attraction. So attraction, it may be ionic attraction, it may be dipole attraction, it may be ion dipole attraction. So attraction, there are different types of the attraction exist between the two particles. So depending upon the type of attraction between the particles and the nature of the particles, the crystalline solid is divided into ionic solid, molecular solid, covalent solid and metallic solid. Now what do you mean by ionic solid? Now in ionic solid, the particles are ions. In ionic solid, the constituent particles are ions. Ion means these are oppositely charged. Suppose NaCl. NaCl means Na plus Cl minus. It is the oppositely charged. So the crystalline solids are made up of these oppositely charged ions. So in crystalline solid, the constituent particles are oppositely charged ions. So here constituent particles are oppositely charged ions. So in ionic solid, constituent particles are oppositely charged ions. Now the next question is, what is the nature of attraction between the two particles in ionic solid? So if the particles are oppositely charged ions, suppose one is positive charge, other is negative charge. The particles are oppositely charged ions. So when the particles, if the particles are oppositely charged ions, then what is the nature of attraction between the two particles? The nature of attraction is the strong electrostatic force of attraction. So if the particles are oppositely charged, then the attraction between the two oppositely charged particles is called electrostatic force of attraction. So in ionic solid, the particles are oppositely charged ions, and the attraction between these two particles is the electrostatic force of attraction, which is the strongest type of attraction. So in ionic solid, the attraction between the two particles is very strong, and this attraction is electrostatic force of attraction. Now comes to the molecular solid. Molecular solid is again of two types. Molecular solid is of two types. One is non-polar molecular solid, and other is polar molecular solid. Now in molecular solid, what is the nature of the particles? Nature of the particles is molecules. The particle should be molecule. In ionic solid, the particle should be ion. In molecular solid, the particles have to be molecules. Now a molecules can be polar molecule, or a molecule can be non-polar molecule. For example, suppose H2, H2, it is a non-polar molecule. Now suppose HCl, it is a polar molecule. HCl, it is a polar molecule. So the H2, in this molecule, the two atoms is identical, and here the two atoms is dissimilar. So in a molecule, if the atom is dissimilar, then it is called polar, and if the atoms are similar, then it should be non-polar. Also in a molecule, if the dipole moment is 0, in a molecule if the dipole moment is 0, then it is non-polar. If the dipole moment is not equal to 0, then it is polar. So molecular solid means the constituent particle should be molecule. Now these molecules may be polar, or this molecule may be non-polar. If the molecule is non-polar, then the solid is called non-polar molecular solid. That means here the constituent particles are non-polar molecule. And in molecular solid, if the constituent particles are molecules, and if the molecule is polar, then the solid is called polar molecular solid. Now what is the nature of attraction between the two particles in non-polar molecular solid and polar molecular solid? Now in non-polar molecular solid, so here constituent particles are non-polar molecules, and here constituent particles are polar molecules. Now what is the nature of attraction in non-polar molecular solid? So in non-polar molecular solid, there is some kind of attraction between the two molecules, and the nature of attraction is dispersion force. The attraction between the particles in non-polar molecular solid is very weak, and this attraction is called dispersion force. And here in polar molecular solid, the attraction between the constituent particle is dipole-dipole attraction. Clear? Attraction between the molecules in non-polar molecular solid is very weak, and this attraction is called dispersion force. Here the attraction is dispersion force. And here in polar molecular solid, the nature of attraction between the two particles is dipole-dipole attraction. So this is about our molecular solid. Now come to the covalent solid. Now what is the nature of particles in covalent solid? Here in covalent solid, the constituent particles are atoms. Constituent particles are atoms. In covalent solid, constituent particles are atoms. So ionic solid, constituent particles are ions. Molecular solid, constituent particles are molecules. Covalent solid, constituent particles are atoms. Now what is the nature of attraction between the two particles? The nature of attraction between the two particles is strong covalent bond. So in covalent solid, constituent particles are atoms, and these atoms are bonded together with each other by the strong covalent bond. Now next is metallic solid. In metallic solid, the constituent particles are metal cations. In metallic solid, constituent particles are metal cations, and these particles are attracted with each other by the metallic bond. Constituent particles are metal cations, and these particles are attracted with each other by the metallic bond. So this is about the different types of the crystalline solid. So crystalline solid is classified into different types on the basis of the nature of the particles and the type of attraction between the particles. So this is about the type of crystalline solid. So in this video, first we have discussed about the crystalline solid and amorphous solid. So in crystalline solid, we have seen that if the particles are arranged in a regular manner, if there is a pattern of arrangement of the particles, then the solid is called crystalline solid. And if there is no arrangement of the particles, that is the particles are distributed randomly, then the solid is called amorphous solid. Next is crystalline solids are anisotropic in nature. What does it mean? It means that if we measure the different physical properties in different directions, the value will be different. But in amorphous solid, the value of different physical properties in different direction is same, which is it is called isotropy. Next is that crystalline solid have sharp melting point, but amorphous solid does not have a sharp melting point. Crystalline solid have a fixed enthalpy of fusion. Amorphous solid does not have the fixed enthalpy of fusion. Next is, but in this chapter we will discuss in details about the crystalline solid. Amorphous solid is not under our discussion topic. So amorphous solid is not discussed in detail. Just we have the basic idea of the amorphous solid, and we have to discuss in details about the crystalline solids. So next, the types of crystalline solid. Crystalline solids are different types, and the different types is based on the nature of the particles and interparticle force of attraction. So these are the different types of the crystalline solids. So I hope you understand this video class. So up to this is about our first video class of the solid states. Thank you.